if you always have tried to observe the communication between your end user and applications hosted in your Kubernetes cluster, then this episode is for you. We are going to study how to observe an Nginx Ingress Controller. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of a series related to the Nginx controller, but in fact, in reality, it's more related to logs. We will try to answer to one question: is the Nginx controller observable? We will have three distinct solutions in three distinct parts. Part 1, we will explain what is an Ingress controller and look at the Prometheus exporter. Part 2, we will focus on how to retrieve relevant KPI utilizing LogQL. Part 3, we will build a logstream pipeline, extracting our logs and transforming it into a metric. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we are going to learn out of this part 1 of the Nginx controller series. We will do an introduction explaining how to expose your service out of your cluster utilizing, of course, an Ingress controller. Then we will jump into what are the type of metrics that we would like to collect from an Nginx controller to get a good visibility. And then we will present the Prometheus exporter. And of course, like usual, we'll jump into a tutorial. So let's start. So let's jump into the introduction. In Kubernetes, to expose your services out of your cluster, there are several ways to do that. So several solutions. So either we can basically create a service with a specific type called load balancer, and that will help us to expose our service out of the cluster. Just to remind, there are several types of services in Kubernetes. There is the cluster IP, the node port, and last, the load balancer. The service type load balancer will allocate an external IP address to our service. So if you create several load balancer services, it means that we will have several public IP out of our cluster. And as a result, there will be an impact on the cost of our cluster, especially if you're utilizing any cloud provider. Bye-bye! So how can we handle one IP address for several services and have a mechanism that will route the traffic to the right services? So there are two solutions that will allow us to do that. The first one is basically, we introduced it, it's utilizing a service mesh. So if you don't know what is a service mesh, I would recommend to watch the episode dedicated to service mesh and especially to Istio. In this specific episode, we introduced the concept of service mesh and we explained the various components of Istio and what you can achieve with it, especially with the Istio Ingress Gateway combined with gateways and virtual services that will basically help us to achieve what we're looking for. Last, there is another solution that will help us to expose our services out of our cluster. And it's basically utilizing a Kubernetes Ingress controller. So Ingress controller will receive an incoming traffic and route it to the right service. Kubernetes provides, in fact, the interface of the Ingress gateway, but there are no implementations. So if you want to use it, you will have to use an existing implementation of an ingress controller. And there are several ones out there. So there is obviously the Nginx Ingress Controller, we have the HA proxy ingress controller, you have Contour, and you have all those cloud provider solutions. So Azure has one of them, AWS as well. Then you have Traffic, Ambassador, Kong, and so on. Ingress controller will be the main component that will be in charge of receiving the external traffic. Ingress component has a specific structure in Kubernetes. So here is an example of an ingress deployment file. The ingress interface will specify the routing rules to handle the traffic to our application. So let's say we have HTTP domain /app1 where we want to route it to service 1, and we have another path, so my domain /application2, where we want to route it to the service 2. So we will create two backend rules to be able to route the path to application 1, so that will be our service 1, and the path 2 to the service 2. The interface is just the description of the rules. You will need the implementation to basically make the routing happening. The ingress controller will evaluate the defined rules and manage the redirections within our cluster. Because our ingress controller will be the entry point of our cluster, we probably want to get a proper level of observability. Recently, Ingress Controller has introduced several CRDs, custom resource definitions, to enhance the configuration of our ingress. So you have virtual servers, you have a virtual route that will allow us to create traffic splits, routing, and more. You can also configure the size of the number of connections, the size of the upstream queue, and more. Then we have policies to create IP source that will be authorized to interact with our applications. What are the type of metrics we would like to collect from our ingress controller? To measure the health of the ingress controller, we want to report metrics that will help us to understand system metrics, so average CPU usage of the ingress controller, the average memory, so the memory usage of the ingress controller, and then more application metrics like the number of bytes exchanged, the time to first byte, the number of requests splitted by HTTP code, the request time, the client response time, the upstream, downstream, and many more, and much more. What is even more important is to collect the right dimensions that will allow us to filter, to split, and build efficient dashboards. Metric is fine, but remember, our ingress controller will serve various application services, various paths. So it will be very important for us to report the number of requests coming in a given service. So let's see the various options to collect the desired data. So the Nginx Ingress Controller has a status page. The HTTP endpoint, the status page, will report metrics like the active connection, the number of accepts, the handled connections, the requests, and many more. With the help of the status page, Nginx provides a Prometheus exporter that will basically help us to collect those indicators. So here is the link to the official Nginx Prometheus exporter. But keep in mind that few of those metrics will require to enable Prometheus data. So you will have to modify the configuration of your ingress controller to make sure that the Prometheus metrics will be exposed. In fact, it's an environment variable called enable Prometheus metrics that needs to be set to true. And you can also modify, by the way, the port and few other concepts through those environment variables. Of course, you will need to make sure that the port exposing the Prometheus metrics is available and reachable through the Nginx controller. The default port, by the way, is 9113, but this could be, like mentioned, modified by modifying the environment variable. You can customize the port by modifying the environment variable called Prometheus metric listen port. You will be able to retrieve the same level of details providing now the status page, and you will also get information about the worker queue and the last reload. Few metrics like the latency will require to enable an extra module, the latency-metrics, and this one also could be enabled directly from the environment variable. When deploying the Nginx controller in your cluster, you can deploy it in various ways, but you can also do it through a Helm chart. The Helm chart will allow you to automatically enable few settings, like the port of the Prometheus exporter, enabling the Prometheus exporter, and if you want to enable the latency as well. And the Nginx Ingress Controller will be deployed through a stateful set, and all the settings of Nginx will be done with the help of environment variables, like mentioned before, and also a config map that will basically replace the Nginx configuration file. Through that configuration file, you will see that you will be able to adjust your logging format if you want. From the documentation of the Nginx Ingress Controller, there is clearly a process to be diagnosed. In that procedure, it explains to look first at the metric exposed by the Prometheus exporter, but it will give you the basic level of understanding, the level 0. So you will see that you will probably quickly need to jump into the logs produced by the Nginx controller to have more insights and more understanding on what's going on. So it means that logs is the source of truth. It's a great source of information for our observability. So the tutorial. This tutorial will require several things. Of course, we will need a Kubernetes cluster with 1, 2, or 3 nodes. We will have to deploy our Ingress controller, in our case, the Nginx Ingress controller. Then we will expose Prometheus metrics, so we need Prometheus, so we will deploy the Prometheus operator. To able to scrap those new metrics from Nginx, we will have to deploy a service monitor to let Prometheus operator scrap those new metrics. We will deploy a demo app, the Hipster-shop. We will configure the Ingress to expose Grafana on one path and the Hipster-shop on another path. Once the metric has been scrapped from the Nginx exporter, we will connect to Grafana and build a dashboard using Prometheus metrics. All right, so let's start.
All right, so like every tutorials that we deliver on Is It Observable, there will be, of course, a GitHub repository like usual. So here we're looking at the overall GitHub repo that will concern or is related to Nginx in general. And as you can see, there are the 3 solutions exposed. As of now, when I'm recording this episode today, we have only 2 tutorials available. So obviously you will, depending on which part you're looking for, you should click on the right part. So let's start. Today it's the part 1 using Prometheus. So let's click on this one and we'll bring up to the README file related to that episode, which basically use Prometheus. So similar to the previous episodes, you will need, of course, a Kubernetes cluster. So either you can use, as I do, a GCP cluster in GKE, or if you don't want to use this and prefer to use Rancher, you are free to do so without an issue. Of course, as usual, you have to clone that repo, and we will walk through the various steps of the installation. So, like expose, Kubernetes has the interface of Ingress controllers, but it doesn't have the implementation. So we need to install one of the implementation. In our case, it will be the Nginx Ingress controller. So step 1, let's add, I already have done it. So you need to add the Nginx repo to the Helm repo if you want to install it for the help. And I have, the great thing with utilizing Helm is that Helm will provide you a couple of variables with the Helm chart. And this is exactly what we're looking for. We want to enable a few stuff. So we remember we need to enable the latency metrics to expose response times. We want to create automatically the Prometheus exporter. And last, we want to create a config map that will be used for the settings of Nginx. Today, we are not going to touch base on this one, but still, it will be required in any case. All right, so first thing, I will basically copy this command, something like this. So simply run that command. So now I'm running it, so it will deploy our Helm chart with our Ingress controller. So let's have a look. So you can do basically kubectl to see what we have in terms of pods in this default namespace. So we can see that we have our Nginx Ingress, which is running here. We already have one. So the implementation has been deployed. And in fact, as you may not have seen it, but there is also a config map that has been deployed. It's the Nginx configuration that I have forced through the Helm variables. Here I'm precisely, I have a specific name for this Nginx configuration file. So this config map will host our configuration of Nginx, but today in this part, we won't touch it because we are not going to adjust the logging because we're not touching any logs here. So what I would like to do now is to show you, to describe the pod related to Nginx, because you will see that there are several environments, like mentioned, that Nginx use. Here it is. So arguments, in fact. So you can see that all the various modules, the various things related to Nginx are enabled through those arguments. So you can see that we can find the Prometheus metric list import, that the Prometheus exporter has been enabled. So most of the thing here has been created. That's the great news. If you use Helm charts, you don't have to touch base those arguments. But if you want to use it, of course, you have to touch base those deployment files. The thing that I like to do next, because we have an Ingress running now, an Ingress gateway, I'd like to get the IP address of our Ingress controller. Let me run this command. So I have put it already the command to get the variable, but let me remove the rest of the command, so you will be able to see the IP address. So here it is. So here the Ingress controller comes with a service, and here are load balancer services that expose an IP. So here is the IP address of our Ingress gateway. So I will note it down for later on, because I would need to update 2 deployment files. And I'm referring to, here it is, I'm going to show you. Here, the first one is related to the Hipster-shop. So the Hipster-shop, I have added have customized the deployment of the Hipster-shop, and I'm not using any load generator service, like explained at the beginning, but I'm using an Ingress. So here I'm adding an Ingress, and I'm trying to add a new Ingress rule. So here, I don't know if you use nip.io, but nip.io that gives you a local DNS. So for demo purposes, is perfect. So here you can see I have put it online boutique because it's the Hipster-shop. And I need to put the IP address here. So that's why I need the IP address, because we will do a set command to change the configuration of our Ingress. As you can see, this definition of this Ingress is fairly easy. I have only one host, and the path is /, and that will bring me to the front-end service of the Hipster-shop. That's very specific, very basic. I have another one for Grafana as well, that I have prepared as well. So here is the Grafana one. So similar to the online boutique, it's doing the same thing. So I'm replacing the IP address. So now I have like a 2 host names, same thing, and I'm gonna reach out to the path to reach out to the Prometheus Grafana service. All right, so now it's clear. So let's run those 2 commands to update those 2 deployment files here, and I'm gonna paste those in this command line. Yep. So now those 2 deployment files has been updated. So now we have this. The next step that I need to do, of course, is to deploy the Hipster-shop, because we need a Hipster-shop, and then so the only thing that we'll have to do then is to deploy Prometheus with the various exporter, the service monitor, and then we can jump into creating a dashboard. So I'm creating first the namespace for the Hipster-shop, and then we'll have to apply a role binding. There it is. And last, I'm deploying this manifest file that will utilize my Ingress controller. There it is. So you will have to, of course, add the Helm repo for Prometheus, but I already have. So I'm updating all my repo to make sure that I have the latest version of the Prometheus operator, and then I can simply install the. All right, now we have this. Let's do just a kubectl get pods to make sure that we have everything. So the kubestat metric is here, node exporter is there, and Grafana is also there. So let's get the services to see what we have. So we should have a Grafana services, which is here. It's a cluster IP. So I'm gonna I could change it, or I will move it to a node port. So I'm just gonna do kubectl edit, and I'm going to edit the SVC, which is, and I'm going to change it to node port just for the sake of this tutorial. All right. All right, now this has been edited. And last, I would have to go to the repo for Grafana. Here it is, and I'm going to apply my Ingress. Now that we have deployed the Ingress, I'm just going to get the default password of Grafana, which is stored in a secret. So usually it's a prom operator. It's always the prom operator, the default one. So if you want, don't forget to change it. It will be required for security reasons, of course. The other thing that we need that we have not deployed yet is the service monitor. So with the Prometheus operator, you have new custom CRD files that are exposed. And those custom resource, the new CRDs bring a new object called the service monitor. So basically it helps you to configure Prometheus. So you don't have to configure the Prometheus configuration file, because there will be a config map. So here it's make more sense to utilize those objects. So to do that, first thing I do, you create a new service called the Nginx metrics that will collect the metrics from the Nginx Ingress, so the service that we had. So let me apply this one. So it will create a service that will basically expose the various data, and then I will be able to use it in the service monitor directly. So now that we have this, the only thing that we need now after applying this is to jump to Grafana, in fact. So let me go to the GCP console for my case. I have those two two ingress that are currently exposed. So let me test them first. So Hipster-shop is responding. That's perfect. And the other one should go to Grafana, which is great. So admin is the default user, and remember the default password is prom-operator. Now that we have Grafana and our Hipster-shop application working, we can now create a dashboard. So for that, the good news, we don't have to configure anything in Grafana because the data source, because it's been installed with the operator, it's been already configured with Prometheus. So big news. Now let's jump into dashboard. So here, what we're going to do here is create a new dashboard. So now let's add a new panel. So the first panel I want to add is to check, because by looking at the metrics of Nginx, you will see that we have a couple of metrics available. And we will see by playing around that due to the missing dimensions, we won't be able to get the details that we're looking for to get number of connection per endpoints. But the first thing which is important, I think, for us is to check if the Nginx is up or not. So I think that could be a quite interesting indicator. So I'm going to just take that up. So the value is very simple. It will return 1 based on if it's up, or 0 if it's down. So here currently it's a graph. So let's remove that graph and change it with, let's say, a stat like this. So we can do this. So that will be our statistics. Then on the display, we don't need to have the values, to be honest. the last value will be good. All right, like this. This sends better with the value 1 in here. So now we can use a stat, so that will send it. I will just put in area, so it will be colorized everything. And what I would like to do is probably put some thresholds here. So by default with a threshold, so if it's 0, it's going to be an error, of course. And if it's here, okay. I'm going to put green, and here it's going to say 1. All right, so now if it's 1, it's green, and if it's 0, it's going to be basically red. So now we have our great graph just to see the health. Let's save it. So let's say up, Nginx up, something like this. Now we can have this one, so we can put a very small stuff here just to have that as a green, as a reminder. And let's save that dashboard and name it Nginx Ingress Controller, like this. The other thing that we could do is also add another graph. So let's put it. We will adapt, of course, the stuff. So a few things. Let's have a look at the metrics. So let's jump into by selecting Nginx here. So first of all, we have the number of the last reload. So I'm not interested in this. As you can see here, we have the server response latency because we enabled the latency. So we could probably plot some response times stuff. But let's first, before we jump there, let's have a look at a few things. So we have the worker, the virtual. We have now no virtual route or virtual service. So in our case, it doesn't make sense. But you can also basically count the number of servers, the virtual servers, and so on. What I'm interested in is maybe have a graph plotting the accept, the handle, the readings, all the various splitted on all those stuff. So let me grade 1 for the accept. So it's of course it's a counter. So to make the per seconds, like we saw in the PromQL, we will have to do rate, and then over the last let's say 30 seconds, maybe up. I think that would be good. Up, and that's it. So now let's plot. Now we have the number of connection accepted per second. We can add another one. So I'm going to add another metric. So that's going to be. the B. So here we have the first one, and we can do the same one. So let's copy paste this one because it's going to be very similar. And instead of the accepted, we want, we don't want the accept, we want the handle active connection. No, let's split everything. So let's do the number of handled, let's say. All right, so I'm gonna just copy this function here, right? Here it is, and same thing, 30 seconds. And right, both. Now we have the handled and the accept, so to say the value is the same. And now we can also add the number of waiting, so that could be also an interesting indicator. So you can add as many. So you can see that there are counters for accepted, for handled, active. So let's put just the waiting. So let's figure out that we just want to have the wait, right? So right, oh, here it is. So the main problem here, if you look at the data that we are exposing here, you see that there's no labels that will allow us to split by path. We have true ingress, but in that data that I'm getting out of the Prometheus here, I'm not able to split. So, which means we cannot achieve what we were initially looking for, which means basically split the number of connections. So figure out which service gets that connection, and that detail we don't have it. So that's the main problem related to the Prometheus metric. We'll see, and that's why we have other episodes. So let's name this one called it's the Nginx connections per second. So because here we have the various stuff. Let's apply. Let's save. Let's apply it. Here it is. Let's save our dashboards. Let's put this one underneath like this. Now we have now we can add another dashboard. Oh, sorry, another graph. And in this one, I want to have the number of requests coming in. That could be also interesting. So now we have the number of connections, but it could be also relevant to follow the number of requests coming in our ingress. So for this, scroll down, there is a counter in the bottom, say HTTP request, and this is pretty interesting. So similar to what we did before, you can see there is no endpoints for us, so no way of splitting by services. So that's the main problem. So let's put a rate again, because remember it's a counter. So 30 seconds like this. And now we have the number of requests per second coming in our ingress control. So that's going to be number of HTTP. Okay, now we have this stuff. All right, so now it's good. But let's move this one here close to the other one. Oh, not here. Oh, he doesn't want to. All right, never mind. He doesn't like this, so let's put it that way. Maybe he would maybe be more accept what we're looking for. So now we have this. Last thing is the response times. So let's create another one so we can, and we have no worker, so there's no value. So let's have a look at the response times. So this metric is provided by another modules in the status page. So you see here there is the upstream server response time latency. It's a bucket, in fact. So I can see the value here. So and here in this particular case, if we look at the labels available, as you can see, we have the Hipster-shop, online boutique, ingress. So we have the data that we're looking for, and when you have the pod names, this is more precise from our perspective. I know that I have the data that I'm looking for, so I'm gonna do the sum. All right, so now we have the sum of all the of the sound. So now we're gonna do a rate of this one. So that will be the per seconds. So I will have the milliseconds. All right. And over the last 30 seconds again. Here it is. Let's refresh. All right. And now we can do the average. Say average. Oh. And with the average, the good thing is that we would be able to split by the dimension that we're looking for. So we have the pod. Is it the pod? And oh no, the pod name is not the one I was looking for. But if we look at service, let's see. Oh, same thing. It's more the Prometheus endpoint. So we just put the upstream then. Up. All right. So now we have two values: the default Grafana and the Hipster-shop. So there is no major traffic. So that's just response times, latency. Right. And so now we have those stuff. What we could do maybe is put some traffic. So I'm going to go to the Hipster-shop, do some few actions, and go back. So now we should have something here instead of, let's say, put the last 30 minutes. So now we can see this response times coming in with the various data. So this is, as you can see, so now we've created a very basic dashboard. I could also add the worker queues and a few things about the workers, but it won't help us. It won't bring the data that we were looking for, especially for us, where we wanted to split per namespaces. So it's interesting. But it doesn't provide what we're looking for. So that's why we need to jump quickly on the part 2, where we can see how we could give more insights on those dashboards by utilizing logs instead.
All right, so that's it for the part 1 of the Nginx controller series. As you can see, we explained a couple of things. Of course, what is an Ingress controller, the various implementations of the Ingress controllers available in Kubernetes. We looked at the Prometheus exporter that is provided by Nginx, and we built these dashboards in Grafana. So as you can see, it's interesting. It brings the level 0 of understanding of what's going on your Ingress, but it's not enough. We need to extend it. So we will see in the part 2 on how to utilize your logs. All right, see you soon for the part 2.